Hello friends, a warm greetings and welcome to my YouTube channel. First of all, I thank you for taking your valuable time and interest in this another important and also most widely used water quality index method. In this video, we'll be learning about heavy metal pollution index and its calculation procedures using Microsoft Excel. In short, is known as the HPI method. This index method is used mainly for determining the level of heavy metals present in water samples. So, to begin with, for your convenience and information, the content of this video constitutes of the following sections. First, we will talk about the general concept of heavy metals in the environment, and there are different types of index method developed by different researchers for determining the level of heavy metals in the environment, such as soil, sediment, water samples, etc. And HPI is one among those index methods. And after which, we will then dive deeper into the topic, that is the Heavy Metal Pollution Index or the HPI index method. First, we will see who developed the HPI method and then what it is used for. Then next, we will see the formula used for HPI calculation. Then we will see the tabular representations of the values of the different heavy metals and their respective standard limits and desirable limits as prescribed by different recommended agencies such as WHO, EPA, and BIS. And at last, I'll demonstrate to you the hands-on calculation of HPI using Microsoft Excel. To begin with, first of all, let us briefly try to understand what are heavy metals in the environment. Heavy metals are the naturally occurring elements found in the earth crust. Due to this, heavy metals are found to distribute in different living tissues of an organism and also in various components of the environment. However, under natural condition, the concentration or level is estimated to be very low or insignificant with values ranging in part per million or in part per billion. Therefore, at such a low level or concentration, the heavy metals have no significant health impact or pose no potential health risk to any living organisms or the environment. Few examples of heavy metals are arsenic, aluminum, chromium, copper, cadmium, mercury, nickel, lead, and zinc. On the contrary, with modernization, industrialization, and advancement of human civilization over the past decades, various anthropogenic activities such as mining and presence of electrical and electronic industries, electroplating industries, pesticides industries, fertilizers industries, plastic industries, pulp and paper, pharmaceutical industries, industrial emissions, vehicular emissions, to name a few. These activities are known to release quantum amount of various pollutants, including heavy metals, into the different component of the terrestrial as well as aquatic environment, thus resulting into the exponential rise of heavy metals level in the environment. Now, when in the environment, these heavy metals later find their ways into the living organism through soil, drinking water, food, fish, air, etc. And through the process of bioaccumulation and biomagnification, these heavy metals are found to produce an adverse effect on plant, animals, and even on human health. So with this basic explanation, we can conclude that it is vital to monitor and assess the level and the degree of heavy metals in the environment. Generally, concentration of heavy metals is estimated or studied in sample of air, soil, water, plants, animals, sediments, etc. And for studying these, The analytical methods and estimation techniques adopted are totally distinct and different from one another. For example, soil analytical method and estimation techniques is totally different from that of the sediments analytical method and estimation technique. However, after analysis, for easy understanding, the analytical data or results obtained are subjected to different heavy metals indices of choices. These are the list of different widely known heavy metal index methods which have been used by different researchers. In one of my videos uploaded earlier, I shared about geoaccumulation index. If you are interested in geoaccumulation index method, you can check the link in the description given below or in my channel. In this video, we'll be learning about heavy metal pollution index or HPI. This index method was developed by Mohan et al. In the year 1996. The main objective of this index method right from the time this index method was developed was to determine or find out whether any water samples of interest is contaminated or polluted with heavy metals or not. So, how to determine or find this out? Simply, this can be done by analyzing the collected water samples using atomic absorption spectrophotometer or AAS. Then, the analytical results obtained will be subjected to HPI calculation, and after which you will then obtain an HPI value, and that HPI value will ultimately provide you information whether the water samples being analyzed is contaminated with heavy metals or not. For this index method, there are three important points one needs to remember. The number one point to remember is this index method is unlike other heavy metal index methods, where the calculated index value will fall under any of the different classes or range, which then represents the level of heavy metals present in the samples of interest. For example, in geoaccumulation index, the calculated IG value will be based on the calculated value obtained. Then we can determine the classes, which class does it belong to. And from the class, we will then be able to determine the level of contamination. So basically, for example, in IGO accumulation index, when we see if the index class belongs to class 1, it means that the sample is uncontaminated to moderately contaminated. If we see that the index class falls under class 6, then we'll say that the sample is extremely contaminated with heavy metals. But for this particular index method, remember that once calculation of HPI value is completed, remember that the HPI value you will obtain will be either above 100 or below 100. That is, when the HPI value is less than 100, it indicates that the water samples is safe for drinking and is free from heavy metal pollution, because the HPI value for permissible or critical pollution index for drinking water is 100. But if the HPI value you obtain is greater than 100, then it indicates that the water sample is contaminated or polluted with heavy metals. Now, once you are clear with the basic introduction and important information on HPI, we will now move on to the next part of the topic, that is the heavy metal pollution index formula. But before we move into the formula of HPI, you need to know that HPI formula consists of two different parts. The first part is on unit weight and the second part is the sub-index value. So first, let's see the first part of the HPI formula, which is the unit weight or the WI value. Unit weight is inversely proportional to SI, or WI is equal to K divided by SI, where K stands for constant, or if you see in most of the research paper, for this particular heavy metal index method, K value is given as 1 or unity, and where SI stands for the standard permissible limit of the ith parameters. So which means that using this formula we will be calculating for the WI value. Okay, and similarly we'll see for the second part of the formula, which is the sub-index value or the QI value. QI value is given as summation of MI minus II divided by SI minus II into 100. The same formula, sometimes you'll see it is in this format. The only differences you'll see in this part where they give here is the modulus sign. What does it indicate when you have this or when you have this? Basically, any negative values can be ignored for the calculation part. Alright, now let's see in detail about the sub-index value or the QI. Here, MI stands for the monitor value of heavy metals of the ith parameters, which means that is the value that you obtain during the analysis of your sample. That will be your monitor value. And II stands for the ideal value of the ith parameters, and SI is the standard value of the ith parameters. Now, merging the WI and QI formula together, the HPI formula is obtained, and this is the HPI formula. Now, using this formula, calculation of the HPI values for any heavy metals of interest in water samples can be carried out. And the HPI formula is given as HPI is equal to summation of WI by QI divided by summation of WI, where WI stands for the unit weight of the ith parameters and QI is the sub-index value of the ith parameters. Now, from this formula, we found that for calculation of HPI, the following data are required, where K is equal to constant, SI is the standard permissible limit of the ith parameters, M is the monitor value of the heavy metals of the ith parameters, and I is the ideal value of the ith parameters. If you remember what I just shown you earlier, Ki divided by Si is the unit weight or the Wi, right? And if Ki is known, but the only thing which is not known to us is the standard permissible limit of the ith parameters. Similarly, for Qi, the data that we require are the Si, which is the standard permissible limit of the ith parameters. Mi is the monitor value of the ith parameters or the analytical data of the ith parameters, and ii is the ideal value of the ith parameters. For Qi, we found that Si and ii are the things which we don't know as yet. But for Mi, once the analysis is done, the analytical data were being obtained. So from here, from where or how do we get the ideal value or the standard limit values, or in short the Si and the ii values for any heavy metals of interest? The answer is, to obtain the Si and the ii value of any heavy metals of interest, we have to refer to the prescribed standard limit developed by different international and national agency such as the EPA, WHO, or the BIS. In India, we refer to the BIS acceptable limit and standard limit. Similarly, in case if you are not from India, you can refer to your country recommended agency or the EPA or the WHO prescribed limit for different heavy metals in different components of the environment. These different agencies that I have mentioned publish the standard prescribed limits for different environmental parameters including heavy metals. So from these sources, the data for different prescribed limit for different heavy metals in water samples are presented in this table. Here in this table, you can see that for different heavy metals present in water samples, Bureau of Indian Standards provide both the acceptable limit and the permissible limit, whereas WHO and EPA only provide the standard limit for each heavy metals. Keeping this table in mind, the benefit of preparing this table is that it is from this table where you will acquire the SI and the II value. Cool, right? But again, the next question that arises is which values will be for the ith value and which value will be for the SI values. So with this, we now come to the point number 2 that a researcher needs to remember when using HPI method of calculation. For this index method, when you say standard limit or the SI value of the ith heavy metals, then you are referring to the highest value prescribed by the recommended agency selected for the study. And when you say ideal value or the II value, ith heavy metals, then you are referring to the lowest value prescribed by the recommended agency selected for the study. Okay. However, you will come across that in some cases, there will be only one data for a particular heavy metals. In that case, the value will be the SI value and the II value will be 0. Now let's go back to that table. Okay. So from this table, let's find out the SI and the II value of, let's say, arsenic, copper, zinc, and lead. Okay. Since for this, I'll be using the BIS standards. So from here, for arsenic, if you see here, arsenic, where is arsenic? Number 3. For arsenic, you'll have these two values, 0.01 and 0.05, right? So the highest value here will be 0.05 and the lowest value will be 0.01. So your 0.05, which is the highest value, will be your SI value, and your 0.01 value will be the II value. Similarly, for copper, number 9, you have these two values, right? 0.05 and 1.5. Now, since this is the lowest value and this is the highest value, so the 1.5 is the highest value, so it will be the SI value, and 0.05 will be your II value. Similarly, you check for zinc, number 15. 5 is the lowest value and 15 is the highest value. So the highest value will be the SI value and the lowest value will be the II value. And one more, for example, lead. Now check lead. Lead is number 4. Now you see that in BIS, the prescribed limit is only acceptable limit for lead is 0.01 and the other values no relaxation, which means this is the only number that is given here. So which means that for 0.01 will be your SI value, and since there is no other value smaller than 0.01, so therefore the II value for lead will be 0. Okay, so this is how you will acquire your SI and II value for the heavy metals pollution index method of calculation. All right. Next, important point number 3 to remember while using the HPI method of calculation is all analytical data of different heavy metals studied, including the II value and the SI values, which are expressed in mg per liter or part per million, should be converted into part per billion or ppb. This is very important points to remember, right? So now, once you are clear about the integral component of the HPI method, the next and the final stage will be the computation of the HPI method using Microsoft Excel. So, to begin with, for easy understanding of the heavy metal pollution index method, first let us assume that we are collecting water samples from these three different springs, and the water samples collected were then analyzed for arsenic, copper, zinc, mercury, cadmium, nickel, and lead. After analysis, let's assume that the data obtained from the three different sampling stations or these three springs for the different heavy metals analyzed are displayed on the screen. So the value for arsenic for station 1 or spring 1 is this, for station 2 is this much, and it's this much. These are all imaginary data, okay, just for demonstration purpose. Similarly, for this much copper was present in station 1 or spring 1, this much copper is present in spring 2, and this much copper present in spring 3. Similarly, for all other heavy metals and different respective sampling station. However, for the general public or the common man, these data might not give a clear indication or information about the level of heavy metals or their overall influence on the water samples studied. Therefore, to further simplify these data and also to interpret the results easily, the data obtained during laboratory analysis were instead subjected to HPI calculation, and the output of the calculation will give us a single value, that is either less than 100 or above 100, and this will reflect the results and specifically provide information to us whether the samples is contaminated with heavy metals or not. Next, let's open MS Excel sheet, and for demonstration purposes, let's assume that in our hypothetical study, heavy metals are analyzed in the water samples that are arsenic, copper, zinc, mercury, cadmium, nickel, and lead. And in our hypothetical study, there are three sampling stations, and these are the values or the mean value of different heavy metals for different sampling stations. Okay. These data represent the MI values or the monitoring values. And as I said earlier, all analytical data should be in parts per billion or converted to parts per billion. Now, the next important data for calculation of HPI are standard permissible limit and the ideal values, or the SI value and the ideal value. So now, for different heavy metals that we analyze in our hypothetical study, these are the SI value and these are the ideal values, which are in mg per liter. For your information and as a reminder, the SI and II values are obtained from this table, which in turn contain the standard permissible limit for water samples for different heavy metals as prescribed by WHO, EPA and WIS. Okay. Now these are the value for SI value, these are the ideal value. But this value, if you have to use it for HPI calculation, these value have to be converted into ppb. So SI value, which is in mg per liter, if I convert it into ppb, it'll be 0.05 into 1000, you get 50. Similarly, ideal value, which is 0.01, if I convert it into ppb, I have to multiply it by 1000, so it'll be 10. For 1.5, if I multiply by 1000, it will be 1500. 0.05 for copper ideal value, if I multiply by 1000, it will be equal to 50. Similarly, same way you have to do for all these value, you have to multiply by 1000, and now you'll get the SI value and the II value in ppb, because you're going to use it for calculation in ppb, not in mg per liter. Okay. Now for explaining the heavy metal pollution index calculation procedure, please make sure you arrange this data in this format, and then it'll be easier for you to do the calculation, because calculation will be carried out station wise: station 1, station 2, station 3. And in station 1, these are the heavy metals analyzed, and these are the standard permissible limit or the SI value and the ideal value in ppb. Now remember, MI is the monitor value or the value obtained after you analyze the water samples. Let's now take the monitor value for station 1. You have to go back to the sheet where the data is there. Yeah, this one. So what you have to do is just copy your station 1 data. Okay, copy. Okay, copy this data and then paste it here. Paste spatial, go click value. Okay, so this is your mean or monitor value. Now what is WI? Remember the formula? The formula for WI is K by SI. So you just have to put equal sign. K is, remember, the K value is 1 divided by SI. What is SI value here? The SI value is this, right? For arsenic and Turkey, you'll get this. So similarly, so you just have to drag this. For the rest, you'll get the WI value. Now here, MI minus II. Now for this column, MI, just put equal sign. MI, which is this, 0.048 minus II. Minus II is this, right? The ideal value. You'll get it as this much. Similarly, you'll do for the other heavy metals. Now you'll find that here there is a negative sign. Remember, I mentioned that whenever you have a modulus sign, the negative sign will be ignored. Because of the presence of the modulus sign, this value will be no longer minus 9.952, it will be 9.952. Similarly, for the next cell, it will be 47.46, 4956.1, 1.83, 2.94, 19.905, 0.215. Okay, so you have entered all these manually. So see, just cross check in case you have missed typing or something like that. Nothing is okay, it's fine. Now see, this is the purpose where we have the modulus sign. Now all the negative signs are ignored, and now we all have positive values. Now the next column for this QI values, SI minus II is equal to SI. What is SI? SI is this value, right? 50 minus II, whereas II is the ideal value for arsenic. So which is then will be 40. So similarly, since it's the same formula, you can apply for all heavy metals. You just have to drag. Once you have this value like this, next we'll calculate the QI value. So for QI value, it is equal to Mi minus II and within modulus, which is this, divided by Si by II, which is 40, right, into 100. Enter, you get this much of value for QI. So this is how you'll do for the other heavy metals. It's in the same formula, so you just have to drag it. Now you have got this value. Next, since you have got the QI value and the WI value, so we'll get WI QI value here. So just put equals to WI. What is W? Where is WI? WI is 0.02 into QI value is 24.88, right? Correct. Now just the same. Now it's the same can be. You just have to drag for the others heavy metals, right? Now once you have completed this stage, now you have completed for each and every single component of the HPI formula. Now you have to calculate the final part, which is the numerator. The numerator is summation of WI into QI. So just put your click here, go to auto sum, click on sum, and then enter. You'll get this much value. This is the numerator, which is summation of WI QI. This value, right? Now the denominator is summation of WI. So what is WI? The unit weight here. So similarly, just click on this cell, go to auto sum, click on sum, and click enter. So this will be summation of, let's keep it in separate color. Now this will be the summation of WI. This is summation of WI and QI. So HPI formula is equal to summation of WI into QI, which is this, divided by the summation of WI, which is this. So now with this, you'll get this much value. Now let's put this inside the red color. Okay, so like this. So now you will obtain the HPI value for sampling station 1. Okay, so now this is for all the different heavy metals. For station 1 will be 146.33. Then which means that based on this calculation for sampling station 1, we found that the HPI value is greater than 100, which means that the water sample is polluted with heavy metals. Simple as that. Okay, now if you want to calculate the HPI value for each heavy metals in the same table, just have to add the summation of WI here. So what is the WI value? 0.834958,381. Okay, so the WI value is this much, right? Just put it the same to all the different heavy metals. Now you have the WI value here. Now for HPI value for each of these heavy metals will be, starting with arsenic, WIQI value for arsenic is 0.4976, right? Then you divide it by WI value, which is this much. So this will give you the HPI value of arsenic. Similarly, you can just drag for the others. And now from here, from this calculation, you can also find out which heavy metals that has been analyzed contributes to the increase in HPI value for station 1. From here you'll find all these 7 parameters except mercury, all the parameters are below 100. So which means that the main causes for the heavy metal pollution in the water sample in station 1, the main contribution is mercury. Okay, so similarly, in the same way, you'll do the calculation for station 2 and station 3. And in order not to waste time, I've already calculated it. So for station 2, the HPI value is 52.73 and the HPI value for station 3 is 60.39. So in both the case, station 2 and station 3, we found that the HPI value is less than 100, which means that the water sample is safe and free from heavy metals pollution. And in the same way, if I want to calculate the HPI value for each heavy metals, same way, I just take the WIQI value and the WI value. Then these are the values. You'll get the HPI value for each of the heavy metals for station 2. Now you'll see that all the values are less than 100, which means that the water is free from heavy metal pollution. Similarly, for that of station 3, all the values are below 100. So now from here, if I put it all this data together, then I'll get the value as this. The computed HPI value for different station are, for station 1, if I compile it from there, it is 146, see 146.35, and for station 2 it's 52.73, and for station 3 is 60.39. So see, the HPI, overall HPI value for station 1, 2 and 3 are obtained, and from here we can conclude that the water samples collected from station 2 and station 3 were found to be free from heavy metal pollution, whereas station 1 is found to be polluted with heavy metals, particularly with mercury. Okay, so this is how we use the HPI method of calculation in determining how much heavy metal is present in the water sample analyzed, and also if there's any heavy metal present, which heavy metal specifically contributed towards pollution of the water samples. Okay, so this is the procedure for calculation of heavy metal pollution index using Microsoft Excel. With this, to conclude, as you can see, the result presented in D2 format is by far more convincing, more clear, and it's easy to understand and also to interpret. So with this, we have come to an end of this video, and these are the references that I use for preparing for this video. And if you find this video helpful, please kindly like, comment and subscribe to this channel. Your support is always appreciated. Thank you so much, and God blessed.